All right. On these proofs that we're going to look at today, we're just going to kind of take what we did yesterday one step further. So we've already talked about the idea that in similar triangles, the sides are proportional. Right? So once I've shown that these two triangles are similar, then I can claim that corresponding sides create equal ratios. Right? I can say AB over DE is going to be the same fraction as BC over EF. That's going to be the same fraction as AC over DF. So we're going to look at proofs like this. Right? Given that this figure is a parallelogram, prove something like this. Km times LB equals LM times KD. Right? So what we want to do is first prove that we have a pair of similar triangles. But we also want to think about working backwards here. We want to think about this first question. What proportion will produce that product? Km times LB over LM times KD. Okay, so what we want to think about is if I had some proportion and I cross multiply, how would I get this? Okay, well, we want to think about I'm going to divide both sides of this product by something to get back to a proportion that makes sense. Okay? That's the first thing we want to do if we're asked to prove some product like this. We want to think backwards. And so we want to think about, well, I'm going to have to divide this by something. And I'm going to have to divide both sides by something to get back to a proportion that would make sense in terms of similar triangles. So in this example, we've got Km and LB, we've got LM and KD. So what proportion involving those four sides would make sense to produce this? Does anybody see? We're dealing with these four sides here. And sometimes if you don't see it right off the bat, you can do a little bit of guess and check. No, we're not going to use KL as a full line. We want to think about these are going to be similar triangles. So we're going to end up using KM and LM separately. So in our proof, we're going to use that because part of our proof is going to be to show that these two triangles are similar. But right now, first, we just want to kind of think about what proportion is going to get us here. So we're just kind of going back one step.
The two angles, angle N, are vertical angles, so they're congruent, and angle M, KD, and angle M.
Yes, so that's how we're going to prove that the triangles are similar. But before we do that, we want to think about this statement right here. We just want to kind of go back one step and get to a proportion that would ultimately get me there. Right?
Km over ML and KD over BL.
Over ML. What was the other one you said?
KD over BL.
Yeah. Okay. So with the sides that we're given, we want to think about matching up corresponding sides and writing a proportion. So Km over ML, those sides match up, and those would be corresponding sides in these two similar triangles. And KD over BL. So now let's test it. Right? If we cross multiply, do we get this statement here? Very well, bless you. I would be multiplying Km and BL. That's what we have here, except it's LB, but that's the same thing. Right? And then here we would have ML, KD. And again, LM and ML are the same thing, same line. So that is the statement proportion that would get us this product. So really all we're doing is matching up corresponding sides in these two similar triangles. Right? We're writing a proportion saying, oh, this side over this side would equal this side over this side. And we could actually do it the other way by writing big side over little side too. And if I wrote LM over KM, so that would equal BL over KD. That would give me the same thing. If I cross multiply, I'm still going to have LM times KD and KM times LB BL. So all we're doing here, we're given a product like this. So think about the previous step. We're just thinking about writing a proportion that matches up corresponding sides. Okay? So we've already kind of talked about 2 and 3 here in this process. The pair of triangles that we would need to be proven similar are going to be these two right here. Right? So our goal is to prove triangle, we can say BLM, similar to triangle DKM. And then we've already kind of talked about the plan to do that as well. Right? To prove that these two triangles are similar, we could say, well, we've got a pair of vertical angles. Those vertical angles would be congruent. And then since I know this figure is a parallelogram, I know BL and KD are parallel, which means I can claim either pair of alternate interior angles are congruent, and I could claim angle DKM is congruent to angle BLM, or I could actually claim this pair. What's that? So we have all three, but we only need 2, right? So we don't need to write that third pair down.
So with angles, everyone automatically.
Yeah. If we know 2 pairs of angles are congruent, that automatically means the third pair is the same. So let's put all that information together in a proof. Okay. This would be helpful if we could see the picture too. All right. So let's write our proof then. So we're given that this figure is a parallelogram, right? So I know ABCD is a parallelogram. And then we said, well, that means that opposite sides are parallel. So then I could say BC is parallel to AD. So we can just write that as definition of parallelogram. But remember, you may see it actually written out as opposite sides of a parallelogram are parallel. So then from that, if I know those sides are parallel, we can claim either pair of alternate interior angles are congruent. So we can claim these two or these two. Doesn't matter. What's that mean?
So you only need one of those in there, you need both.
Yeah, we could name both of them and then ignore the vertical ones. Yeah, we could do that too. So yeah, we can do that. So I could say angle LBM is congruent to angle KDM. That would be alternate interior. Then we can name the other pair of alternate interior. We can say angle BLM is congruent to angle DKM. Also because they are alternate interior. And then we have enough to say that these triangles are congruent. Or, I'm sorry, not congruent, similar. So now we can say triangle BLM is similar to triangle DKM by angle. Then we can claim, after I know triangles are similar, we can claim that corresponding sides are proportional. So we said that we're going to have to use this pair of sides and this pair to get to what we actually want. Right? So we can set it up as MK over LM is equal to KD over LB. So we don't really have a nice short way of saying that. And we're just going to have to write out that corresponding sides of similar triangles are proportional. Right? Yeah, we had that like nice CPCTC for congruent triangles. We don't really have a nice shortcut like that. Corresponding sides of
CSS.
CSS GP.
That works.
Corresponding sides of
Legislation.
similar triangles are proportional. Yeah.
Take it.
So then our final step is what we actually want to prove, and that multiplication statement where we cross multiply here, and they said LB times MK equals LM times KD. So what allows me to do that then? Yeah, it's just the multiplication property. We're multiplying both sides of the equation by the same thing. Okay, so this is what these types of proofs are going to look like. Okay, the first 5 steps in this case are the same thing as yesterday. First, proving that the triangles are similar, and 99 times out of 100, the best way to do that is to use angle. All we have to do is show that two pairs of angles are congruent. But then once we know the triangles are similar, I can go one step further and claim that pairs of sides are corresponding sides. Corresponding pairs of sides are proportional. Questions? Do we want to do another one together? You guys think we're okay? Another one? So if you feel confident, then you don't have to listen to me, but I will go through another one here. You can. Alright, so on this next example, we are given that A, B, and C, D are parallel. So that'll be my first line here. B is parallel to CD. Well, if I know that those opposite sides are parallel, we can claim that alternate interior angles are congruent. So we could actually say C and B are congruent, or we could say angles A and D. I'll do angles C and B because they would be alternate interior angles. And then, just like the last one, we could claim the other pair of alternate interior angles are congruent. But just to give a different example here, I'll use the pair of vertical angles. So we can say angle AEB is congruent to angle DEC. That would be vertical. So now I've got enough to prove that the triangles are similar. I've got two pairs of congruent angles. So I can say triangle AEB is similar to triangle DEC by angle. And now, once I've got the triangles similar, now I can claim that corresponding sides are proportional. So that's actually all we want to prove here. We only have one more line instead of two more like in the first example. So AE and ED would be corresponding sides, and BE and CE would be corresponding sides. So I can just claim that AE over ED is equal to BE over EC because corresponding sides of similar triangles are proportional. So in this one, we didn't have to take it one step further and write out a multiplication statement. I think in the next one we do, though. Yeah. We want to do another one? Or you guys feel like you can try the next one? Ruler. Ask two questions. The last one? Okay. So, let's go. We've got 9 minutes left. Let's go ahead and see what we can do with the next one then. Just finishing the rest of this paper is going to be our homework. Okay, so there's one more proof on the front, and then